In section 1 of chapter 7, we are going to be getting away from rational functions and going towards radicals. I was about to say what they are, but we're going to be going towards radicals and simplifying radicals. In this first lesson, this is largely going to be a review of what you did back in, say, middle school through Algebra 1. This is going to seem very, very similar, maybe a little bit like higher difficulty, but roughly the same concepts. This is the only slide I have for notes because I want to review and recap the fundamental process on how we simplify radicals. So problem number 1, I have the square root of 4. I'm sure all of you could look at that and just immediately scream out the answer, which I don't want you to do. What I would like you to internalize is how we get to that answer, because the process is going to help us with these later problems. The reason the square root of 4 is equal to 2 is because the square root is a second root. There's an invisible 2 that's right there. And what we're doing is we're looking for two numbers that multiply to give us 4. The square root of 4 could be rewritten as the square root of 2 times 2. We have a pair of 2's. Since we're looking for a pair of numbers, they can be pulled outside of the radical as a 2, and that would be our answer. The reason I want to highlight that process is if the 4 is not something you can square root, this process still works. Problem number 2, I have the square root of 25. That's the same thing as the square root of 5 times 5. Again, this is a second root, so I'm looking for a pair of values. I have a pair of 5's. They can be taken out, and that'll just be 5. Problem 3 is where I decide to start throwing variables into the mix. I have the square root of 81x squared. The square root of 81 is just 9 times 9, and x squared is just x times x. I have a pair of 9's. They can be pulled out. I have a pair of x's. They can also be pulled out. Therefore, the answer is 9 times x. Now, there is an issue with what I just did, but we'll go over that in a couple problems. Problem number 4, same thing. I have the square root of 121 x to the 4th. That is the same thing as the square root of 11 times 11 times x times x times x times x. This is a second root, so we're looking for pairs. I have a pair of 11's. I have this pair of x's, and I have this pair of x's. So that's going to turn into 11 times x, which is 11x squared. You might begin to notice one of the issues with my technique is variables. As soon as I start having really, really high powers, I don't want to have to write out 8 x's if I have x to the 8th power. So what we do is we analyze, is there a shortcut for this? When it comes to variables, what we do is we take the power of the variable, the 4, and you divide it by the index. That is to say the type of radical it is. If it's a square root, a second root, I'm going to take the power of 4 and divide it by 2. 4 divided by 2 is 2. That's why 2 x's came out. So for problems like number 5, where I have an x to the 6th power, I could write x 6 times, or I could just take the 6 and divide it by the index, which will be 3. So this is the same thing as 4 times the third root of, and now 27 is 3 times 3 times 3, times x to the 6th. Now we're looking for 3 of the same value. I have a group of 3, so they can get pulled out. So it's 4 times 3 times x to the 6th. If it's under a cube root, 6 divided by 3 is 2. 4 times 3 is 12. 12 times x squared is 12x squared. Problem number 6. I have 3 times the 4th root of 16x to the 12th. That is going to be 3 times the 4th root of 2 times 2 times 2 times 2 times x to the 12th. Here's a group of 4 2's. They can be pulled out. So it's 3 times 2, and then times x to the, take the 12 divided by 4, you're going to get x to the 3rd power. 3 times 2 is 6, x to the 3rd. Problem 7 is the first one that's going to have a little bit of a hiccup that you're going to see in most of your problems. I'm taking the negative cube root of 16x to the 11th. This would turn into negative cube root of 2 times 2 times 2 times 2 times x to the 11th. There are two things that make this problem difficult. First, I'm looking for groups of 3. I have 4 2's, meaning those 3 2's can get pulled out, but that individual 2's got to remain underneath the cube root. That's the first issue. So we're going to have negative 2, and then there's still going to be a cube root with a 2 underneath it, because one of them had to be left behind. Second problem is you take the power of 11 and divide it by 3. 3 does not go into 11 nicely, which is also why there's going to be some x's that remain. 11 divided by 3 is 3, so 3 of my x's are going to get pulled out, but there's going to be 2 remaining, so 2 remain underneath the cube root. This is largely what you're going to be facing in today's lesson. You're going to be simplifying radicals where the coefficient, the number, does not perfectly be able to be square rooted or cube rooted, so some of it's going to remain. And the same thing with the variable. The index is not going to perfectly divide into the power of the variable, meaning some of the variables, the x's, will also stay behind. And then lastly, problem number 8, division. This is the same thing as negative square root of 72x to the 9th over the square root of 49. You're square rooting an entire fraction. It's the same thing as square rooting the numerator and denominator individually. So that's going to be equal to the square root of 72 is the same thing as the square root of 36 times 2 times x to the 9th over the square root of 49, which is just 7. So that's going to turn into the negative 6x to the 9 divided by 2 is 4 with a remainder of 1 all over 7. There is my solution.